All right, so we're going to take a look at the very last section, solving trig equations. And up to this point, the trig identities from the formula sheet, those identities are used to simplify expressions, evaluate trig expressions, and also to solve trig equations. We're going to be taking a look at, we're not going to be taking a look at any inequalities, only the equations. And as we kind of mentioned in the last class, we're going to deal with trig equations that can be solved by linear methods. And a linear method, all right, is the steps we use to just solve a linear equation. And here are those 6 steps. The first step says clear any parentheses that you may have, combine like terms on both sides of your equation. And I'm just going to put a star by the fourth when it says isolate, isolate the variable term, which means that we want the unknown or the trig function on the side of the equation by itself. And we simply move all other items to the opposite side. Then we'll isolate for our variable. And what that means is we'll take any coefficient and we will multiply or divide, because we only want the trig function by itself, and it should have an understood coefficient of 1, right? Just like any linear equation. And then the 6th step is the check. All right. So just an example of this, let's say 2x minus 1 is equal to 0, and let's just say we want to solve. Right, this is a linear equation because my variable is x, and that variable is raised to the first power. So any equation that has a variable, and keep in mind that for your trig expressions, the sign x is understood to be raised to the first power. If you see something like sine square, okay, that will be understood to be raised to the second power. All right, but since we have x to the first power, that would make this linear. And so anything that's linear, you just want to follow these steps. All right. So I don't have any parentheses on either side of my equation. There are no like terms on either side. So both sides are simplified. The most important thing is to isolate your variable term, which means that you want to ultimately have x, which is the unknown, on the side of the equation by itself. All right, so in order to do that, I'm going to move the other items over. So on the actual notes, it says to add or subtract, or use addition or subtraction. I'm going to simply transpose. Transpose means that once you move one term or any term across your equal sign, you simply change its sign. All right. So I'm going to let my variable remain on the left. So this little V stands for variable, kind of using this as a guide. I only want my constants on the right. So remember, a constant is just a number. It can be negative, it can be positive. It can be a decimal or a fraction, but there is no variable attached. So on the left-hand side, I only want variables. 2x is a variable, so it's okay on the left. -1 is not a variable, so I'm going to transpose it to the opposite side of my equation. So when I transpose, you simply change the sign. We always want to solve for x, never for 2x or 3x or anything like that. So the opposite of multiplying x by 2 is to divide by 2. So if I divide both sides by 2, I have my variable on the side of the equation by itself. It has a coefficient of 1, and everything else is on the other side. All right, so this is a linear method. On the notes itself, and we kind of worked this one out last time, but I'm just kind of putting a solution here. It says solve 2 times the sine of x minus 1 is equal to 0 over the interval from 0 to 2 pi. So you want to keep in mind that the solutions are angle measures in radian form. So if they give you degree measures to start, you should answer in degree measure. But if they're giving you the interval in radians, you want to make sure to answer in radians. All right, so since this is a linear equation, and what makes it linear is the fact that this sign, it doesn't actually have a power, but that's understood to be the first power. Right? So this would constitute a linear equation. So we ultimately want to isolate for the sine of x. So the first thing that's done here is on my left hand side, I have 2 terms. 2 times the sine of x is my first term, and -1 is my second term. I want to isolate for the variable sine. So we're going to take -1 and transpose to the other side. All right, so we have 2 sine x is equal to 1. And then in order to isolate for the sine of x, the opposite of multiplying 2 by the sine of x is to divide by 2. Right, so we have isolated for our unknown, which is the sine of x is equal to 1/2. And then I think we interpreted this. What angle in the interval from 0 to 2 pi? Notice that 0 has a bracket, so that means that we can actually include 0 as an answer. Since the 2 pi is not enclosed in a bracket, it's enclosed in a set of parentheses, you cannot use 2 pi as a solution. Simply because of the parentheses. And then 0 and 2 pi, technically they're the same, right? You go around 360. So 0 supersedes the 2 pi. Okay. All right, so what angle in the interval from 0 to 2 pi has a sine, which is the y coordinate, of 1/2. So keep in mind that this is not one of those arc functions. So remember when we're in the arc function section, the arc functions, there was a certain interval in which that arc function could be found. Since this is not an arc function, I'm going to use the interval given from 0 to 2 pi. So we want to know what angle in this interval has a sine or a y coordinate of 1/2. So I'm going to pull up the function values chart. Formula sheet. Now they actually give you one in the homework, but for whatever reason, when I tried to print that out, it did not print out right. Okay, let me just bring this up real quick. All right, so there is one embedded in the homework. Okay. Right. And I did try to print it out, but for whatever reason, it didn't print these values out. All right, but that same document that I handed out is in the formula sheet section. All right, so let me just bring that up. Okay, this is what we're actually using. Where is? All right, so I have these up side by side. So what angle any interval from 0 to 2 pi. So this is that unit circle which goes from 0 to 2 pi, has a sine function or a y value of positive 1/2. Well, I can see that pi over 6 has a sine value of 1/2, so pi over 6 is a solution. And if we scroll down, it seems like 5 pi over 6 has a sine function of positive 1/2. All right, so those would be the solutions: pi over 6 and 5 pi over 6. All right, you can also check these, just as you can check your, just bring this up, just as you can check your algebraic solution, right? I could just substitute x for 1/2 and both sides should be equal. You can also check your trig equations. You just want to make sure that if you check, you always use your original function. So just to check this out real quick, 2 times the sine of x minus 1 equal to 0. You only want to check one solution at a time, though. So one of the solutions is pi over 6. So I'm going to substitute x for pi over 6. And then I want to see if both sides equal. So the first thing I'm going to do is evaluate the sine of pi over 6. So I can evaluate that by using the unit circle function of values. So pi over 6 is 30 degrees. The sine is 1/2, right? So the sine of pi over 6 is 1/2. All right. So now I follow order operations. Please excuse my dear Aunt Sally. The first thing I'm going to do is multiply. 2 times 1/2 is 1. 1 minus 1 is 0, and both sides are equal. All right, so pi over 6 is a solution. 5 pi over 6 is also a solution. All right, 5 pi over 6, if I were just to pencil whip that a little bit, 5 pi over 6, it still has a sine value of 1/2. So 5 pi over 6 would check out as well. All right, and that's the linear method. So now here are a couple of problems that deal with the linear method. All right. Now, as far as the numbers are concerned, usually I put like example 1, example 2, and all of that. This starts out with question number 2 because this is similar to your question number 2. All right, so they're not like in 1, 2, 3 order if you're looking through this. All right. So this is the first example, and it should be similar to your question number 2, and it asks to solve any interval from 0 to 2 pi. So this, sometimes they may write it out in interval, well, with inequalities. Sometimes they may write it out in interval notation. All right, but notice that 0 is less than or equal to 2 pi, so that's the bracket. And theta is less than 2 pi, so that less than, since there is no equal to bar, that is the parenthesis. All right, so if you get 2 pi as a solution, you cannot use it, right? But you can use 0. All right, so we're asked to solve the tangent of theta is equal to the square root of 3. Well, first off, is this a linear equation or not? Well, I'm looking at my tangent and I don't see any squares. So if it's like tangent square theta, this would constitute a quadratic. Or if I had something higher. But since there is no exponent, that is an understood exponent of 1. Right? So I would use a linear method. So the most important thing on a linear method is to isolate your variable term. Right. So if I go back, what is the variable term? Well, theta is an unknown angle. So this tangent of theta is my variable term. And it's isolated. I mean, it's on the same side of the equation by itself, and everything else is on the other side. So for this particular problem, I don't have to algebraically manipulate it, simply because it's linear and my variable function is isolated. So unlike the first one, you got to clean it up a little bit. You had to isolate for the sign. The tangent is already isolated. There is no coefficient other than 1. So we can proceed to interpret it. Okay. So I'm going to interpret this as what angle in the interval from 0 to 2 pi has a tangent, and tangent is y over x, value of square root of 3. All right, so we don't have to algebraic manipulate this. This is linear. It's already isolated for the variable term. So now I'm going to pull up, I'm going to try to pull these up at the same time. All right, so I simply want to look down the tangent column, and I want to find all values that have a tangent of positive, because the sign matters, positive square root of 3. And it seems that pi over 3 has a tangent of positive square root of 3, and 4 pi over 3. So theta is going to equal to pi over 3 and 4 pi over 3. Now you're going to notice sometimes there are 2 answers, sometimes there's 1 answer, sometimes there's 4 answers. But they give you a hint on how many answers you can have. All right, so many questions about this first example. Pretty straightforward, right? All right, let's look at question number 4. So the first thing I would do is I would determine if it's linear or quadratic, because we're only going to deal with 2 types of trig functions. Since this sign is not squared, it's raised to the first power, this is a linear trig function. So in order to solve it, I want to isolate for the sine function. Right. So if I go back to my steps, there are no parentheses. I can't combine any like terms. But I would like for the coefficient of the sine value to be positive 1, not a 2. So the opposite of multiplying 2 by the sine is to divide by 2, right? So whatever you do to one side, you have to do the same thing to the other side. So I'm going to divide both sides by 2. So once I divide both sides by 2, on the left-hand side, I'm left with the sine of theta. And on the right-hand side, I'm left with negative square root of 2 over 2. Okay, so now that the variable term is isolated, the coefficient is 1, I can now interpret it. So this is what angle in the interval from 0 to 2 pi has a sine, which is the y coordinate, of negative square root of 2 over 2. All right, so if you look at your unit circle function of values, I'm looking in the sign column, and it looks like 5 power 4 has a sign value of negative square root of 2 over 2 and 7 pi over 4. So theta is equal to 5 pi over 4 and 7 pi over 4. So this had two solutions. All right. So it seems like the linear problems are pretty straightforward. All right, now this is the next one. It's question number 6, and I actually skipped over some stuff that's on the notes. But at first glance, would this be considered linear or is it quadratic? Okay. Now it appears to be linear because I don't see any coefficients past the first power. But I do see that these things over here being multiplied, like secant x times the sine of x minus 2 times the sine of x equal to 0. Now this one actually categorizes as a quadratic. I'll show you why in a second though. All right. Just notice in the other problems, there was only one trig function. This one only had a sine, this one only had a tangent, and then the other one we did only had a sine function. This problem has some multiplication in it. Right? So now I want to talk about the quadratic method. And as far as quadratic equations are concerned, I'm going to just go down to this method thing. There's actually 4 ways to solve a quadratic equation. You could use the square root property. And that's what I kind of have on here. These are just all of the different methods. They're like 6 methods you can use. The only 2 methods we're using in this class is the square root property. And the square root property says if x squared equal to c, then x is equal to plus or minus square root of c. In order to use this square root property, you must have a certain form. So for a quadratic equation, this is what the standard form looks like. Standard form of a quadratic equation. Okay, is ax squared plus bx plus c equals to 0. So everybody kind of seen that before, right? So you have a squared term. And when I say squared term, that just means that the variable on the x is squared. You have a first degree term. So when I say first degree term, that just means the variable term with the exponent of 1. And then you have a constant term. In order to use the square root property, you must only have the squared term. There is no first degree term, but you do have a constant. So if you have an x in your equation, you can't use the square root property. You must have only the squared term the squared term and the constant. All right, so here's an example. So let's say you got something like this: x squared minus 4 is equal to 0. You could use, we're going to talk about factoring in a minute, but you could use the square root property because you have the right condition. You have your squared term and you have your constant. In order to use the square root property, you must isolate for your squared term. So that's what's kind of implied in this formula. The squared term is on the side by itself. Everything is on the other side. So I could transpose -4. I could just change the sign, right? And now I have the proper form to use the square root property. So the square root property says that you take the square root of both sides, and the side that is not squared has the sprout that's plus or minus. So if I apply the square root property, I would square x squared. So the square root and square are going to cancel. The side that's not squared has the sprout this plus or minus square root deal. And the square root of 4 is perfectly 2, so x is equal to plus or minus 2, so that means x can equal to -2 or +2. So you're going to see this in one of these problems. All right. Here's some other methods. I'm just going to kind of just talk through them. You can, this is called factor by grouping. This really isn't used too much. You can take a trinomial, remember it's a trinomial, it's a polynomial with 3 terms. You could split up the middle term, and then you can do some factoring, right? And then you can use what's called a zero factor property. You could, I don't know what this is called. This is, well, you're going to see something similar to number 2. Factoring takes on a lot of different forms. To factor means to rewrite as a product. So I have x squared plus 2x. You can actually factor out the greatest common factor, which is x. You can always check your greatest common factor by multiplying. You should always be able to come back to your starting point. X times x is x squared. X times 2 is 2x. All right, and then we can use something called the zero factor property, which I'm going to explain in a second. All right, but factoring can be as simple as factoring out the greatest common factor. There's something called complete the square. This is by far the most complicated method in the world to use, and I would just kind of stay away from it if possible. But we won't see that in this class. Number 3 says to factor. We're going to see this factoring. So if you are the factor, I'm going to go back down. Here are the steps to factor. I thought I put it on here somewhere. Oh, I didn't copy it over. All right, so here are the steps. Copy. Okay, here are the steps to factor. And I actually have a problem. Give me 1 second to find it. And this is coming out of another class. I just sort of took the same thing. This was it. Negative 3x squared plus 5x plus 2. Let me just write that down. Negative 3x squared. Now, I don't actually have this one on the 7 notes, so you may want to write this down. Now, this is just to review factoring. You will probably not have one this involved a factor, but okay, here are the steps. The first step is to first realize that you have a quadratic equation. Once you realize that you have a quadratic equation, you must get the quadratic equation in standard form. Standard form means that you must make the equation equal 0. Equal to 0, and let me stop my phone from ringing. Okay, make the equation equal to 0, and the coefficient of the squared term is positive. So if I'm looking at my equation, okay, it's quadratic because the largest power is a square. You may have other powers, but if the largest power is a square, that automatically makes it a quadratic. So it's in standard form because it's set equal to 0, but the coefficient of the squared term is negative, and I want to make it positive. So in order to do that, I'm simply just going to multiply both sides by a -1. So I'm going to multiply the left-hand side by -1. And whatever you do to one side, you do the same thing to the other. So I'm going to multiply that by -1. So now I'm going to remove the parentheses and distribute. So the only thing that's really going to do is change my signs, right? A -1 times a negative 3x squared is positive 3x squared. -1 times 5x is negative 5x. -1 times -1 times positive 2 is -2. And I'm going to bring down equal 0. Right? So that's the first thing. The squared term has to be positive, and then it's got to be set equal to 0. The second step says factor the quadratic expression. So I'm going to make 2 sets of parentheses, and it's still set equal to 0. Keep in mind that factoring and the FOIL method, that first, outer, inner, last, they're reverse processes. So that means that whatever I put in my first terms, when I multiply it, should give me a 3x squared. Whatever numbers I put in for my last term, I should be able to multiply those and get a -2. The middle term is when I multiply my outermost terms and my innermost terms. I have to get the middle term, which is -5x. So this is like a trial and error type thing. So the only numbers I'm going to concentrate on are factors of my first coefficient. So when I say factors, I'm talking about multiplication. The only way I can get a 3 is a 1 times 3 or 3 times 1, right? And I'm going to look at factors of my last term. The only factors of 2 are just 1 and 2. But since I have a -2, I could have a -1 times a +2, or I could have a +1 times a -2. So I'm just limiting the amount of numbers I'm using. So I'm only taking factors of the first term, which is 3, and factors of the last term. So since there's only 2 factors of 3, I'm going to put 3x in the first set, and I'm going to put x in the second set. Because if I multiply 3 times x is what? 3x squared. So now I have a little bit some combinations I can put in for my other numbers. I'm going to put in -1 and a +2. And then I'm going to check, because it's easy to get the first and the last, but the middle term doesn't always match up. So you may have to play with your numbers a little bit. So 3 times x is 3x squared. That gives me my first term. -1 times +2 is a -2. That gives me my last term. Now if I take my outermost, 3x times +2, that gives me +6x. If I multiply my middle terms, -1 times x is -x. When I combine those, do I get -5x? Well, if I have -x plus 6x, that's going to give me a +5x. So I want to change my numbers around, because I don't get the right middle term. So I'm going to change these around to make this a +1. And I'm going to make that a -2. And now I'm going to see if the middle term is correct. So 3x times x, that's 3x squared. Positive times a negative. 1 times 2 is -2. So now if I take my outermost, 3x times -2 is -6x. 1 times x is +x. And now if I combine my middle terms, x minus 6x is -5x. So this is the correct factorization. Is everybody okay with the factoring part? All right, so I'm just going to rewrite this. So I have 3x plus 1 times x minus 2 equal to 0. So once all the dust settles, this is what we have. So it's factored. It was written out as a trinomial, and now it's written as something times something else is set equal to 0. The last part says to use the zero factor property. So this is the zero factor property. It says if a times b is equal to 0, then we can let a equal 0 and b equal 0. So that is the zero factor property. So looking back at our equation, that's exactly what we have. A is the quantity 3x plus 1, because that's in a set of parentheses. B is the quantity x minus 2, because that's in a set of parentheses. And now I can let a equal 0, so I can set 3x plus 1 equals 0. And I can set b, which is x minus 2, equal to 0. So now we have linear equations. So in order to solve these, I can isolate for the variable. So to solve this first equation, I'm going to subtract 1 and then divide by 3. So I got -1/2 as a solution. And for the next one, I'm going to add 2. So the two solutions are negative 1/3 and 2. So you can factor trig equations. All right, so the two methods that we're going to use are, well, actually, I should say 3 methods, because we're going to use the factor method. You're going to see the complete the square deal. And then you're also going to see something similar to this second, where you can simply factor out the greatest common factor. Okay. This number 2 method is used to answer the next problem. And I've lost it. This one. So true indeed, it is linear. I mean, there's no variable squared. But there's 2 terms. And both of these terms have something common to both of them. So whatever's common in both, I can factor that out. So secant x times sine x minus 2 times the sine of x have what trig function in common? They both have the sine function in common, right? So I can factor out the sine of x. So what's left on the inside of parentheses? Well, sine times what will give us secant x times the sine of x? Just the secant of x, right? Because we factored that out. And then the sine of x times what will give us negative 2 sine x? I believe that's going to be minus 2. Remember, you should always be able to multiply and come back to your starting point. So if I were to reverse this process, the sine of x times secant x is just secant x times sine of x. The sine of x times negative 2 is negative 2 sine x, right? So this is factored. And it's set equal to 0. So this is sort of like A, right? This is B. And they're both equal to 0. So I'm kind of encapsulating everything that's inside of a set of parentheses as one term. Even though it's 2, but since it's encased in a set of parentheses, we're going to count that as one term, right? Or one factor. So I can set A equal to 0. And I can set B, which is secant x minus 2 equal to 0. You can only do this now if your equation is equal to 0. So if this was like equal to 2 or equal to 3, I would have to do something else. But you can only use the 0 factor property if it's set equal to 0. So now we have 2 linear equations. If I look at the first one, the sine of x is equal to 0. Well, my trig function is already isolated, right? So I don't have to manipulate it any. It's already on one side. So I can simply, from this point, interpret it, right? So this is what angle or angles have a sine, and again, that's the y value of 0. Okay. So in order to find those angles. So this is still saying 0 to 2 pi. All right, so we're going to look at the sine. And it seems like the angles that have a sine of 0 are 0 radians. And it looks like pi. So x is equal to 0 and pi. Now the second one is linear, but the secant function is not on the side of the equation by itself. It's not isolated. But we can isolate it by moving -2 to the opposite side. So we can actually transpose -2. So once we transpose it, it becomes the secant of x is equal to +2. So here again, this is now linear. We've isolated for the secant of x, and everything else is on the other side. So now we can interpret it. So we're going to interpret this as what angles, angle or angles, has a secant, and the secant is r over x. Value of +2. So I'm going to look at the function value sheet. We're going to go down the secant column, and we're looking for +2. So it looks like pi over 3 has a secant value of +2 and 5 pi over 3. So here we have pi over 3 and 5 pi over 3. So altogether we have 0 pi over 3 and 5 pi over 3. So even though the original problem was linear, we still use a quadratic method. Okay. All right. All right, now the next problem, it says find all solutions exactly over the interval from 0 to 2 pi, 4 times the cosine squared minus 3 equal to 0. So first off, it is what type of equation? Well, the largest power is a square, so this would be a quadratic function. So if it's a quadratic function, I could either try to factor out a greatest common factor, and I don't see any greatest common factors between the 4 cosine square and the -3. I could try to factor it, but normally when you factor something, you need 3 terms. I'm noticing though I have the squared term alone. So based on the methods we use to solve, if you're trying to solve a problem and there is only the squared term, oh, it's up here, then you could use that square root property, which means you could isolate for the squared term. So that means we need to put cosine square on the side of the equation by itself, move everything else to the other side, use the square root property, pull out the 2 numbers, and then answer the problem. So for this one, I'm going to use the square root property simply because I only have the squared variable. So I'm going to isolate for the squared variable. So So the first thing I'm going to do is I'm going to transpose -3. I'm going to add 3 to both sides. And I want to make sure that the coefficient of my squared term is a 1, not a 4. So the opposite of multiplying cosine squared by 4 is to divide by 4, right? So we have cosine squared theta is equal to 3/4. But I want to solve it for cosine, not cosine square. So this is where we use the square root property. So if we were to square cosine squared theta, the square root and the square would cancel. The other side has to sprout a what? It has to sprout a plus or minus, and it has to sprout the square root. This is just a part of the square root property procedure. So now I'm going to put in 3/4. Okay. All right. Now we have the square root of 3/4, and we're going to simplify that a little bit. There's something called a quotient rule for radicals. And I think we talked about this before, but if you have the nth root of a divided by b, you can separate that out as the nth root of a divided by the nth root of b. And the only way you really want to do something like this if you're dealing with like a perfect square. So I'm going to rewrite this as the cosine of theta is equal to plus or minus square root of 3 over square root of 4. And the square root of 4 is perfectly what? 2. So the cosine of theta is equal to plus or minus square root of 3 over 2. So cosine of theta can equal to positive square root of 3 over 2 and negative square root of 3 over 2. All right, so we use the square root property. We isolate it for cosine square. Then once we use the square root property, right, we had to sprout the plus or minus and the square root on that right-hand side. And then we use the quotient rule for radicals to simplify it up. So now we can interpret it. Right, so we're going to interpret this as what angles in the interval of 0 to 2 pi have a cosine, which is x coordinate, of positive square root of 3 over 2 and negative square root of 3 over 2. So I'm looking for both the positive and the negative. So if we pull up the function value sheet, so I want the cosine, so that is the first column, and we want both positive and negative square root of 3 over 2, so it looks like pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So that is pi over 6, 5 pi over 6. I thought I had these answers written down. I thought I had them written down. Pi over 6 cosine cosine power 6, 5 power 6, 7, 5 power 6, 7, and then 11 power 6, I believe. Cosine. Okay, I'm supposed to be looking at cosine. Power 6, 5 power 6, 7, pi over 6, and 11 power 6. So those would be the 4 solutions. So here again, now you can check these things, even though I'm not going the extra step to check them, you can check them. Just make sure to use your original equation. All right, any questions about that number 11? All right, now the last one is number 12. So notice on number 12, we have find all solutions exactly on the interval 0 to 2 pi. 2 cosine squared t, so I have the squared term, plus cosine t, I have the first degree term, is equal to 1. So this is a quadratic equation, and I have the second degree term, the first degree term, and then I had a constant. So I'm going to factor it. So the first thing we got to do in order to factor, we got to put it in standard form. So we got to make it equal 0. So that means I'm going to transpose the 1 to the right-hand side. So I'm simply going to change my sign. That would make it equal 0. And since the coefficient of my squared term is already positive, I don't have to multiply by anything. So this should now read 2 cosine squared t plus cosine t minus 1 is equal to 0. And this is standard form. So now that we have a trinomial, we are going to factor it. Okay, and it still equals 0. So now we're going to factor the same way we did the algebraic equation. So we're using the reverse FOIL method. So whatever I put in for my first terms, I must be able to multiply and get a 2 cosine squared t. Whatever I put in for my last terms, I should be able to multiply to get negative 1. In order to check the middle term, that means that the outermost and the innermost should give us the middle term, which is the cosine of t. So I'm simply going to look at factors of the first term. So the only factors of 2 are just 2 times 1. And I'm going to look at factors of the last term. And the only way I can get a negative 1 is either a negative 1 and a positive 1 or a positive 1 and a negative 1. So you got to like check all possible combinations. But notice I'm just limiting my numbers. All right. So for the first set, I'm going to put 2 cosine t. And for the first number in the second set, I'm going to put cosine t. Because if I multiply these things together, 2 cosine t times cosine t is 2 cosine squared t. So what about my last terms? I believe I'm going to use a negative 1 and a positive 1. So it's easy to get the first and the last, right? 2 cosine t times cosine t is 2 cosine squared t. A -1 times a +1 is a -1. So I get the first and the last. The trick is the middle term. So to make sure our middle terms match up, I'm going to multiply our outermost terms. 2 cosine t times 1 is still 2 cosine t. -1 times cosine t is negative cosine t. So now this is what 2 cosine t looks like. 2 cosine t is just 1 cosine t plus another cosine t, right? So altogether I got like 2 cosine t's. Negative cosine t looks like this, negative cosine t. So if you were to add all that stuff up together, what's going to happen? Well, this negative cosine t is going to cancel out one of the positive cosine t's, so I have left positive cosine t, which is the correct middle term. So now that we have the correct factorization, I'm just going to rewrite that. 2 cosine t minus 1 times cosine t plus 1 equal to 0. So we're going to look at 2 cosine t minus 1 is A. We're going to look at the next factor, cosine t plus 1 is B. And we're going to use the 0 factor property. I'm going to set each one of those factors equal to 0. And now we're going to solve. All right, so notice they're now linear. So in order to solve this for cosine t, I'm going to add 1 to both sides and divide by 2. So cosine t is equal to 1/2. In order to solve that second equation for the cosine of t, I'm going to subtract 1 from both sides. So cosine t is equal to -1. Both of these equations have the trig function isolated and everything else on the other side. So now we can interpret it, right? All right, so for this one, it's what angle in the interval 0 to 2 pi has a cosine, which is x coordinate of positive 1/2. Right, so if we look at the unit circle function of values, the cosine is the first column. Be careful because on mine, the cosine is the first column, but if you're using what's in XYZ homework, they're using the sign. So please be careful on that. I just noticed that today when I was printing this out. All right. So let me just close those down. All right, so the cosine is positive 1/2. It looks like pi over 3 and 5 pi over 3. So t is equal to pi over 3 and 5 pi over 3 for that equation. And what angle or angles in 0 to 2 pi have a cosine of -1? So here again, the cosine is the first, and -1 is pi only. Right. So my three values are pi, and notice how they give us three blanks: pi, 5 pi over 3, and pi.